Hello and welcome to this video that goes through some momentum practice questions for A-level. These are the questions 7 to 9. So the first question we have is: two campers dock a canoe, one camper steps onto the dock. Camper has a mass of 80 kilograms and moves forward at 4 meters per second. With what speed and direction do the canoe and the other camper move if their combined mass is 110 kilograms? So in this situation here we have so we're going to assume that they're docking a canoe. So you've got a man here, two men, and in your position before, and then here's your dock. So initially, as they're coming into dock, we're going to assume that it's stationary, so it's right next to the dock. So assume that the boat is stationary, so V is equal to 0. And the mass of this, so we know that the mass of one of the campers is 80, that's the guy that's stepping off. And we know that the mass of the other person and the canoe is 110 kilograms. So therefore the overall mass of this system is going to be 190 kilograms. This doesn't really matter though, because as V equals 0, the momentum before has to equal 0 kilograms meters per second, because momentum equals mass times velocity, and velocity is 0. So afterwards, what happens is that one of the guys gets onto the dock and has a forward velocity of 4 meters per second, and we know that this mass is 80 kilograms. And the question is, what happens to the canoe and the guy on the canoe? What happens to them? So they have a mass of 110 kilograms and their velocity is unknown. So we know the basic rules of mechanics is that momentum is momentum before equals momentum afterwards. So here the momentum afterwards is equal to 0. Therefore we know momentum afterwards is also equal to 110 times the velocity that we don't know, plus 4 times 80. From here we then put this in, so we say that 0 equals 110V plus 4 times 80, which is 320. And then from here we just rearrange, so we do minus 320 equals 110V, and then we do minus 320 divided by 110, which gives you minus 2.9 meters per second. So the fact that it's negative is completely fine, so minus 9.291 to 3 significant figures. So although in this question here the speed's in 4.0, so I would just leave it to minus 2.9. So that's completely fine. That's just saying that the canoe moves in this direction with a velocity of minus 2.9 meters per second. And obviously that's the answer we get in the question as well. Question 8. 52 kilogram woman riding on a 10 kilogram car is moving east at 5 meters per second. The woman jumps off the front of the car and lands on the ground at 7 meters eastward. What is the final velocity of the cart? So to start off with, we've got the woman on the cart. It doesn't really matter how we draw this, so she's moving along. So we say that the mass of this situation is 50 for the woman and 10 for the cart, so in total it's 60 kilograms, and it's moving eastward, so we're going to say it's moving in this direction, velocity of 5 meters per second. It says the woman jumps off the front of the car and lands on the ground at 7 meters per second eastward. So this time, this is the cart, this is the woman. So she's got a mass of 50 kilograms and her velocity is 7 meters per second in this direction. So we're taking that as positive. What is the final velocity of the cart? So we know that the mass is equal to 10 kilograms and the velocity is unknown. So first of all, we find the momentum before. In this case, they're both together. Treat them as one system. So it's just going to be the mass is 60 times 5. So that's going to equal 300 kilograms meters per second. Remember, we treat it together as a system because they're on top of each other and they move. So yeah, we just the overall mass of the system times 5. In this situation though, we split it up because now the woman has jumped off, so we know that her speed and her mass, so it's going to be 50 times 7, and then plus 10 times v. We also know that momentum before is equal to momentum afterwards, so we know that this must equal 300. First thing we do then is we can do 50 times 7, which is 350, plus 10v equals 300. Subtract 50 on both sides. 7. What is the final velocity of the clock? So then we should move, so it should be 10v is equal to minus 50. So then v is equal to minus 5 meters per second. Just checking the answer. So just running a 10 kilogram cart, so it should be 60 times 5 for the first one. The woman jumps off, so it's 7 times 50, which is 350. What's the final velocity of the cart? So minus 5 meters per second is what I get for the cart. And I think that is the correct answer. I actually don't know how they got the 4.6. So just to justify the answer, so we know that initially the system is together. It's going to be because they're moving on top of each other, which is riding on a 10 kilogram cart. So it's the mass of them together is going is 60 times 5. Even if you were to split that up, you would get the same momentum. Yeah, so it's 300 and then 300 going that way. Yeah, I think the answer in this question is wrong. I think the velocity is minus 5 meters per second. I'm not sure how you can get 4.6 from this. Although if you know in the comments, let me know if there's a mistake in my calculations, but I believe that the trolley will move westward, which is correct, but at 5 meters per second, not at 4.6. I'm not sure how they got that one. But yeah, that's my solution to the question. Question 9. A 45 kilogram ice skater stands at rest on the ice. A friend tosses the skater a 5 kilogram ball. The skater and the ball then move backwards across the ice with a speed of 0.5 meters per second. What was the speed of the ball at the moment just before the skater caught it? So in this situation we have the skater here. He's got a mass of 45 kilograms and the velocity is equal to 0, and a ball is thrown at them. And just before, so the ball has a mass of 5 kilograms, but the velocity we don't know. We're not sure what that velocity is at this stage. And then afterwards, when the skater has caught it, we know that the mass is equal to 45 plus 5, which is 50 kilograms, and they move backwards across the ice. They move back. The skater stands at rest on the ice. Friend tosses the skater. The skater move backwards across the ice. So it must be in this one at 0.5 meters per second. So we're going to say it's thrown in this direction. The skater catches it and moves in that way. So we're going to take going to the right as positive, and the skater will move to the right in this direction. So we say it's 0.5 meters per second. So here we're going to then find. So we know that the momentum before is equal to 5 times v plus 0, because the person is stationary. And then we know in the next one we got is momentum afterwards is equal to 50 times 0.5, which is equal to 25 kilograms meter per second. So we know that the momentum afterwards is 25, so therefore we know momentum before is equal to momentum afterwards. So momentum before must equal 25. So 25 is equal to 5v. So then from here, v is equal to 5 meters per second. So therefore, the answer, what was the speed of the ball? Well, we don't need that direction. So the speed of the ball is just 5 meters per second. And that brings the end of this question. If you have any further questions, please let me know.